Sorry. Hello, but hello, Karen. Thank you. Hello. Thank you, Karen. Not that it's a competition. Oh, hello, Gabriella. Oh, all right. So that's two. There, now we're rock. Oh, now we're go. All right. All right. So thank you, Gabriella. Thank you, Karen. Here we go. Good afternoon, Samantha. Hello, Alfred. Good afternoon, Duran. Good afternoon, good. Well, yes. Good afternoon, Brandon. Good afternoon, Genesis. Good afternoon, Sydney. Good afternoon, Roger. Good afternoon, Ariana. Hello, Yanelli. Good afternoon, Matthew. Good afternoon, Emanuela. Oh, and there's Joanne. Awesome. There's Kaya. Awesome. Thank you, and Gabriella. And thank you, Yanelli, for the picture. Thank you, Alfred, for the avatar, which I still can't pronounce. With a name like Yaverbaum, it has to be weird. Okay. Hello, everybody. Thank you for the hellos. Thank you. Okay. We're good. Did I say Emanuela? Yes. Good afternoon. Okay. So we're more people. Sorry. Okay. We're gonna get more and more into like physics and like equations. Today, little couple. So every day, more and more physics, less and less other things. But at all times, always you can stop and ask questions in chat or in private chat or blah blah blah. But more and more, I'm just trying to get myself into the material here. So some bookkeeping, housekeeping things first. Okay. Hopefully you're all see like tons of you handed in homework. Let me back up for a second. The thing we're going to talk about mostly today is the physics concepts. Oops, sorry. That are operating in homework 1 and homework 2. We're going to specifically talk about them in the context of homework 1. That is today. Today, we'll finally put homework 1 to rest. We will go over the last harder bits of homework 1. We'll answer any questions about homework 1, and we'll show you how it produces the equations that we need for homework 2 and beyond. So we're going to finish homework 1 today. We're not going to talk directly about homework 2 today. As far as grades or work or whatever, to be clear, like many of you turned in a draft of homework 1 for last time and you got tons of points. Many of you got feedback, and then many of you used that feedback, turned around, turned in it again, and got more points, which is great. Like we're on the same page. That's good. For those of you who turned in homework 1 again and got more points, terrific. Probably, if you already did that, you probably have so many points on the homework already that I'm probably pretty satisfied that you get what's going on. And as far as I'm concerned, you could move on. Like as long as it's clear what would make perfection in the future, like I'm good if you're good. But if you still want all the points, you're welcome to turn in it again. No problem. Again, just remember, every one of these homeworks is just like practice for what I'm looking for in exams in physics 203 and physics 204. And then exams are just practice for what I think is really the right practice for journal articles, poster presentations, research publications in physics in general. Like it's all not arbitrary. It's all meant to be a method that works. So as many times as you want to resubmit until you get all the points, Quark plus America, go for it. But you don't have to. If you've got most of the points, it's fine. Those of you who haven't resubmitted yet, homework 1, totally still fine. You totally still can. No problem. It just, it's going to start piling up for you, but no problem. There's a couple of you, there's like 4 of you or so. I might even want to acknowledge by name. Yeah, actually, I'm going to quickly. Wait, this is a good thing, not a bad thing. This is a compliment, not a insult, whatever. I don't want to embarrass anybody, but let me just make something clear. Sorry. More people coming up on 1 second. Uh, just to make it absolutely clear, since we're still getting to know each other. Hold on. Bear with me for a second. Oh, what? Oh, sorry. Oh, okay. No, with number line, I think all of you who turned it in with revisions have gotten the more points already, except maybe one person turned it in like right before class, which is fine. I just then haven't gotten it yet. I think there's one person. That's fine. Well, maybe. Yeah, okay. I'll just say like Sonam, yay, thank you, awesome. I see it, I got it. I haven't done it yet, but you're good. Okay, but now, so that's homework 1. So I hope that's clear. If it's not clear, tell me. But then, as far as homework 2, to be clear, average speed, there was confusion of what day it was due. I think I kept accidentally, I meant in my mind for average speed number 2 homework to be due today. I can't remember, in one of the classes, I accidentally assigned it for Wednesday. And then once I did that, I couldn't change it. I don't know if it was your class. Was it your class? Uh, Whatever it is, let me say, if you've turned in average speed homework 2, most of you have gotten feedback on it already. This is what I guess I was going to say. But for or many of you have gotten feedback already on average speed, homework 2, which was technically, I think, in my mind, it was meant to be due today. You could stop. Well, what it was. Yeah, I think it was due today. But let me acknowledge publicly right now, like Ariana, Sam, this is a good thing, not a bad thing. Like like I have the following people: Ariana, thank you; Sam, thank you; Erica, thank you; Karen, thank you; Matthew, thank you; Andre, which I'm still saying wrong. Correct me again. Wait. And you even gave me a nickname, I think. But all right, tell me in the chat again. But thank you, Brian. Thank you, Alfred. Thank you, Joran. Thank you, Brandon. Thank you. I got it. And you might have even done it really early, but for whatever reason, I fell behind. So I have it, and I know you're on time, and I haven't marked it yet. I mean, I guess technically it was due this period. So anyway, but for all of you, just to acknowledge, we're not going over homework 2 yet today. We're going to go over it next class. So it's not too late to turn it in. I mean, if it said it was, I mean, maybe we're getting to the point now where you might get all the points if the first draft wasn't turned in on time, but whatever. Homework 3, train of thought, that is due next class, because these things are starting to get piled up already faster than I can go over them. So to be clear, homework 3, the next thing that's due, that one is super important, but in a different way. You'll notice when you look at homework 3 that it doesn't really involve numbers or equations or anything like that. It's far more conceptual. It's super important, but it is not mathematical. So for homework number 3, number 1, yes, you still have to do the basic format of separate sheets of paper. Don't copy and paste my questions. Make the question clear, like do step 1, step 2, where it's asking for diagrams, do diagrams. But there's not really a problem solving. Often it's like a multiple choice or whatever. So you don't have to strictly follow the 5-step method for homework 3. I think I said that in Google Classroom, but you don't have to strictly follow the method. You just have to present all the work in a clear, thorough way. And I'm telling you right now, since it's conceptual and it's like opinions for the moment, that's meant to generate a discussion that we'll have Wednesday or next week. If you do it at all and you do it properly and you do it neatly and clearly, you're going to get all the points for it as long as it's turned in on time. So don't stress it, like have fun with it, basically. There's no like wrong answers as such for homework 3. Just do it and do it thoroughly. Think about it. Hopefully it's a little bit fun to think about, and we're going to have a discussion about it, and it does have a purpose. It's not random discussion, but you'll get all the points as long as you do it thoroughly and clearly on time. So if things are starting to pile up for you, don't let that one stress you out. So basically, bottom line for all this, there's still time for anybody and everybody to do anything and everything. I hope that sort of makes sense. I'm going back over. So that said, what I'm about to do is turn our attention. Well, I'm about to, sorry. Woo, that's not what I meant to show you. Okay. So we're about, to close down the shop on homework 1 and get the concepts out of homework 1 that we need to move on. We're going to get our first equations, our first real equation, which you would use for homework 2. This is generally the way I like to do these things. This equation that's on the board right here is what I'm going to discuss today. It's not expected that you already fully understand it. It's the purpose of today. By the end of today, I would assume that this equation is now a known truth. Like it is now, because we're establishing it in class today. I mean, technically it was established on the first sheet, but it just wasn't written as an equation. It was like written in English. But this concept, whatever's on the board right here in red, is now, especially because there's a triple equal sign, because it's a definition, it's going to be always true. I don't know whether it looks easy or hard to you, but whether it's easy or it's hard, it's super true. It's super fundamental. So what I'm really trying to say is, when in doubt right now, when you have to do a step 3 GDP for any homework problem you're doing or any exam problem, like if you're looking for an example of what I mean by a step 3, what's a GDP, what's a general definition of principle, almost always for a little while, it would be this. This is the one thing that we're going to know concretely by the end of today. And so it's always acceptable as a step 3 GDP. Okay. I'm particularly trying to talk about homework 2 right now. This is totally acceptable for, or an English version of it is totally acceptable for step 3 for almost all of the problems on homework 2. But hint, hint, for those of you who've even already gotten homework 2 back, or have gotten some comments on it, not only is this acceptable for most of the questions on homework 2, but it's actually kind of the only thing that's acceptable for 3. What I'm really getting at, just to get us, like, if you've already done homework 2, even though we're not going to talk about it fully today, the last 2 questions in homework 2 are slightly trickier than they look, maybe. They're not trick questions, but the answers are not as obvious as they might appear. I mean, to be really blunt, the Hill figure problem of homework 2, the Hill figure problem of homework 2, I don't believe that the answer is 50 miles or 50 whatever kilometers. I don't remember what the units were. It's not 50. It feels like it should be 50, but it's not 50. And that's not a trick. It's meant to start opening up our chakras and like actually thinking carefully about physics. And my hint is that if you got, now you're not getting points off just for like wrong answers, but if you got 50 as an answer for the Hill figure problem, what that honestly actually means is that you either didn't do a step 3, a GDP, or you made up something that seems right to you, that seems like maybe you got it from a math class or something. If you look at your Hill figure problem, I'll move on in a second, but this is just, and there's, again, because you could still totally resubmit and still get all the points. It's like not too late at all. So I'm just saying this as advice. If you believe that the answer is 50 for the Hill figure problem in homework 2, it's actually because you made up something to be true for your step 3 rather than using something that we know from the class to be true. So from here on in, so reconsider and think about it, like in your own, you have more time to think about it. Going forward, when we say step 3 GDP, general definition or principle, we mean something that somewhere has been established or at least mentioned in the class, even if it's on a written piece of paper that we haven't discussed yet. It's something from the class. So we're building logically from as we go throughout. All right. So that's enough. So, and if you have any questions about that, feel free to ask me. But this equation is where we're going to go today. So we're going to do it in the context of talking about homework 1, the number line homework. Is there anything else I forgot? Again, stop me. If there's any main thing I was supposed to say, or I asked you to remind me, like you'd stop me and tell me, but I'm about to go over homework number 1. This is the way I'm planning on doing it. I believe that I gave you answers to the first set of exercises in homework 1, right? Like I scrawled them out, I put them on the notes at the end of last class, and I uploaded the PDF. And right at the end of class, some people, thankfully, right at the end of class, noticed that for question 6 in part, they noticed that in part 2, question 6, in class, I think I'd said average velocity equals positive 3 feet per second, but some people right after class noticed, no, it should be -3. Now I corrected that in the PDF, like the PDF of notes of class notes 2 you have should say question 6 of part 2, average velocity is -3. But please note that, like, if you didn't catch that, that's the case. If you have no idea what I'm talking about, don't be ashamed to ask, like, Professor, I have no idea what you're talking about. But why I'm talking about all this is I'm about to say, I'm going to pause for a second and let you think and make sure you're okay. But I'm going to say the answers that I gave you for homework 1 for the first 2 parts, as long as you're cool with those answers and you see how I got them, even if you got them wrong originally or whatever, if you see how I got them and you have no questions, I'm going to hop straight to part 3 where I think there's more thought involved. But I want to pause first to make sure if you have any questions anywhere in parts 1 or 2, let's answer those first now before I go on. So I'm going to pause for a second. This is time for you to ask anything that is unclear, or like, how did I get an answer, or why did I get an answer for anything from part 1 or 2 on homework 1. I'm going to pause for a second. Okay. So I'm going to take it. Please, if you're cool for me to go on and start talking about the part 3 of the homework, if you're cool for me to go on and actually talk about how I got answers for the last 2 questions of the homework, please raise your electronic hand or some kind of hand. Wait, let me do the. Oh, thank you, Samantha. I appreciate it. Thank you, Sonal. Thank you, Ariana. Thank you, Sydney. Thank you, Brian. Thank you, Skylar. Thank you, Sana. Thank you, Erica. Okay, thank you, Drawn. All right, cool. That's almost a quorum. All right, thank you, Kaya. And how about that? Cool, Genesis. Thank you. All right. And how about this? The control of the experiment. Raise your hand if you hear me right now. And keep your hand up. Just keep your hand up if you hear me right now at all. That's cool. All right. So we're all together. All right. That's good enough for me. It's not everybody, but it's gonna. All right. You can put your hand. All right. Thank you. You can put your hands down. So I'm going on. So here's homework number 1, part 3. I did a new sketch. And I'm solving question 1 of part 3. And you can put your hands down now if you're cool, unless you have a question. But yeah, put your hands down if you're okay. All right. Awesome. Or do you guys have or okay. Oh, and Kaya and Drawn, you're cool, right? I mean, you're good. Okay, so you can put your hands down if you want. Okay, all right, thank you. Or Kaya, are you good? Or are you? Okay, if you have a question, feel free to just shout out. But if okay, um, okay, changing the view. Okay, so here's question 1 of part 3. So I redrew the diagram. There's my diagram. And I'm noting that in each one of those intervals, there's a constant velocity. Okay. So then I put down my step 2. So that's my step 1, the diagram and the fact pattern. Then step 2 is at t equals 7, what's the position? Now I just wrote x equals question mark. So I'm going to pause for a second now. I wrote at t equals 7, what's x? Now, we've never formally talked about x yet. Like, I mean, you've seen x your whole life in algebra classes and other physics classes and stuff, but like, I'm just writing down x now. So let's pause for a second and be formal about this, because as we go forward, like I said, you're allowed to use anything that gets produced in the class, but you shouldn't be expected to have to use anything that doesn't get established in the class. Like, we're not supposed to be making up truths, and you're not really allowed to use anything that didn't get established in class. Like, we're trying to be logical in physics. The whole thing of physics is to start with things that we all agree are definitively, self-evidently true, and then build from that to things that are not so obvious, or in fact are surprising. So before I go on to step 3, GDP, which, yes, spoiler alert, I think my step 3 GDP is going to be this red thing right here. But let me talk about it for a minute. So I'm going to do right now, and I promise we're going to finish this homework by today. I promise you we're going to move on to homework 2 by Wednesday. But forgive me for this now instructor sidebar. Like, so now I'm going like, so in other words, this is what your homework should look like, more or less, right? This is what I'm expecting your homework would look like for this question. But now I'm going to go off in yellow. Now I'm going to talk to you as a teacher. So this goes as notes or whatever. Like, let's be explicit about a couple things. Some things that will be obvious to you, some of you, or remembered from high school, but have some subtleties that get more advanced now for the college level or whatever. So here's the deal. We are physicists. We are looking at only 3 things for the rest of our lives in physics. We are always looking at stuff in space and time. Those 3 things: stuff, mass in space and time. All of physics is about where is something when. Like all of physics is about things moving through space and time and us predicting where something's going to be in the future or how long it's going to take to get to a certain place in the future. Or if we're at John Jay and we're in the forensic science department, maybe what we're doing is figuring out where something was in the past, i.e., solving crimes, right? We're either looking at the wheres and the whens in the future, or we're retrodicting the wheres and the whens in the past. But that's all we're ever doing in physics, no matter how advanced it is space, time, and stuff. So let's be sort of clear about space and time. This chapter, this first topic in physics that okay, cool, thank you, got it. I appreciate that, by the way. This topic that we're doing in physics now, if you were to look it up in a textbook that is not required for this class, or you're trying to cross, like you don't understand anything I'm talking about, and you're trying to find a Khan Academy video or a three brown, one blue video or something that has anything to do with what I'm talking about. What I'm talking about is a chapter known in physics, usually on the side here as 1D kinematics. We're talking about 1D kinematics. Kinematics means motion. Kinematics means motion. All of physics is about motion. So strictly speaking, when people say kinematics, like in chapter 1 of this physics textbook, kinematics, what they really mean is we're right now first defining the terms of motion. We're just establishing what means what when things are moving in space and time, and what we're focusing on when things move in space and time. So everything we're doing now is defining the terms of motion, but specifically in 1D. Meaning in one dimension of space right now. That's why this first homework problem is just a dude going back and forth in a number line. That may seem sort of artificial, but that is how physics begins, is we're looking at particles, masses, as they travel within one dimension of space in one dimension of time. This is not because physics is science fiction. It's not because we believe there's only one dimension of space. We believe there's more dimensions of space. You exist in at least 3 dimensions of space. What we believe in physics always is that we start from the most simple and we build with one new variable or level of complexity at a time. We always want to make things as simple as we possibly can without making them too simple. So the theory is that if we fully understand what's going on within one dimension of space and one dimension of time, then we could put one dimension on top of another dimension. We could take the rules of one dimension and apply them twice, in effect, to see what's happening in a plane. And then we'll do it one more time to see what's happening in a cube. And that's what's going to happen in this class. So we start with one dimension because it's a fundamental building block of space. If you're moving within one dimension from here on in, we're going to use the letter X as a variable to denote or to track where you are in space. So X is a variable that, like, it varies, it changes, and the value of that variable, the numerical value of that variable, measured in meters or sometimes feet or something, whatever, is your current point in space, as in the dot that you're at within a larger line of space. So X stands for a particular position. If X is 7, that's position 7, that's the 7-meter mark, etc. Similarly, lowercase t is a variable that stands for a point in time, such as 7 o'clock or 7 minutes, 33 seconds from the beginning of the experiment or whatever. So there's one value of X at a given point, and it's called a position. There's one value of T at a given moment, and that's called an instant or a moment. So X and T are variables that we'll use for the rest of our lives in physics, and they refer to one point at a time. Okay. Notation, no. So what I'm doing, this is all part of a professor sidebar here, instructor sidebar. Like, I just want to, because what we're doing now, I mean, of course, this is really boring in a way, and maybe it's old news to many of you, but just to be clear what I'm doing, I'm trying to solve homework one. I'm going to solve homework one. I'm going to get answers that maybe many of you got in your own way without all of this. But really, what I'm really doing is trying to convert our English concepts that got established in homework one. I'm trying to convert them into symbolic or notation. We're trying to establish the notation that we're going to use from here on in to be able to, instead of writing out huge long English sentences, write out specific symbols and put them together and make equations from now on. So I'm just trying to right now formally establish what symbols we use for what concepts. So in other words, we're doing notation. So from now on, if you ever see X with a subscript 0 to the right of it, the way that's read in English, if you see X with sub 0, you don't read it out loud like X sub 0. You read it out loud X naught. Naught is like a British word that means nothing. So if I see X sub 0, I read it as X naught. And what that means is X is the value of X. Sorry, the value of X when time equals 0. In other words, it means the very first value of X. That's what X naught means. It means in English, if X stands for position, then X naught stands for the initial position. If you took physics in high school or watched videos, sometimes people will call this X sub I. Sometimes people will even call it X sub 1, which is a little confusing, I know. And those all mean, if you understand those things, they all mean the same thing. But in standard college physics, whatever, most physicists really will call the very, very initial value of X, they'll call it X sub 0. They'll read it out loud as X naught, and that means the value of X when the value of T was 0. Now that's an important piece of notation we're going to use for the rest of our lives. It actually applies in general. When I say squiggly sub 0, I mean, if you have any variable at all from now on, if we start using V to mean velocity, or we start using A to mean acceleration, or F to mean force, whatever, then from now on, if you have F sub 0, that means the value of F at time equals 0. Okay, so that's true. Notice, hold on. Notice, pretty important and maybe confusing to some people the first time they see this, X sub 0 does not mean the same thing as 0. Like, by definition, like the definition of X sub 0 is not the value 0. X sub 0 does not triple equal sign equal 0. I'm not saying that X sub 0 could never be 0. Sometimes X sub 0 double equal sign equals 0. Remember, triple equal sign means equal by definition, like necessarily equal. Double equal sign means equal by discovery. Sometimes in an experiment, we discover that the value of X naught is 0, but it doesn't have to be. And in fact, for example, in the case of this homework problem, the very first value of X, the value of X when T was 0 was 4, was positive 4, right? Because that's where the dude was when this experiment started. Okay. So if I just said, I'm still in sidebar here, this is still instructor sidebar. If we're saying that the value, that any variable sub 0 means the value of that variable when T equals 0, well, then actually that means by definition that T sub 0 does, T sub 0 does always equal 0. So I'm not trying to confuse you, but it is a subtle point. I'm saying that X sub 0 could be anything like positive 4 or negative 4, whatever. But T sub 0 actually always does have to be 0, because T sub 0 by definition means the value of T when T equals 0, right? Anything sub 0 means the value of that thing when T equals 0. So T sub 0 does actually mean the value of T when time was 0, the initial value of time. In physics, that's always 0. Now, what does that mean? What does time equals 0 mean in physics? When we're doing physics, when we're solving physics problems and stuff, time equals 0 is not some heady psychedelic thing. Time equals 0 does not mean the Big Bang necessarily, or the Garden of Eden. Time equals 0 means the beginning of the particular experiment that you're observing, or the particular theoretical problem that you're considering. Time equals 0 means the beginning of the interval under consideration. So concretely speaking, time equals 0 means when the stopwatch started. Like when you started paying attention, you started your stopwatch. So even, for example, in this homework problem for this whole thing, when we say the instructor started at position 0, I'm sorry, when we say that the instructor here for this problem started at position 4, you might well ask, wait, how did he get to 4? Like, how did he get to 4? Why didn't he start at 0? And if he did start at 4, why didn't we just call that 0 or something? Like, what we're really saying is the instructor had been running around for a while doing whatever. And then we came in and started paying attention. We started our stopwatch at when he happened to be at the 4-meter mark. Like maybe that was a dumb thing to do, but that's what we did. Okay, so t equals 0 means from now on when the stopwatch started, and that means for any given interval that you're paying attention to. You could even take an experiment and zoom in, as we're going to do. I'm not just being abstract. Well, I am being abstract, but like in the case of today's problem that we have to solve, you notice like by the time we're getting to the last 2 questions of the homework, we're asking about things that happen at the end of the experiment. So when I solve those problems, I'm going to zoom in and just look at the last bit of the experiment. And I'm just going to, in my mind, start my stopwatch like at the beginning of the last interval of the experiment. And in my mind, I'm going to call that time equals 0. Like, if that makes any sense. That's the point of this. So as far as notation from here on in, like x and x naught are particular points. Some textbooks might call them, well, okay. X and x naught are particular positions, particular points on an axis or on a number line. They are positions. X minus x naught from now on. So I'm trying to convert our English into notation and equations now. From now on, if you want to say displacement, the difference between 2 positions, a final position and an initial position, if you want to know how far something got, taking into account its direction, from now on, you would write x minus x naught. And that's what stands for displacement. So I'm trying to say x is position. X naught is a particular, let me start again. X is a particular position, the position you're looking at now. You might call it final position. X naught is a particular position, the position where things started. You call that initial position. X minus x naught, that's displacement. Displacement isn't x, it's x minus x naught, if that, okay? So I'm saying x minus x naught is displacement. If you've taken physics before, or you look at Khan Academy video or like other things, which is fine, all of which is fine, or you came from another college or blah, 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 like you might write displacement as xf minus xi, like final minus initial, that's fine. Or you might write x2 minus x1, it's fine. Like that's not the way I'm going to write them, but like they all mean the same thing. If any of those is clear to you, that's what I'm talking about. But I just want you to note that displacement is not a value, it's an interval between 2 values. Okay. More notation. We're still in the sidebar here. I apologize. I promise we are going to finish this homework today. We have 40 more minutes. And you can be able to ask more. Well, you can ask questions still at any time. I know I'm just like talking to. Would I see a hand of it? Yeah, I'm just talking to, and I know this is, we just need to have this clear so it's clear. So more notation. From now on, if we put a bar over something, we mean the average value of that variable. If we put a bar over a variable, we mean the average value of that variable. So from now on, assuming that V stands for velocity, even though I don't really quite yet know what velocity means, like if I'm like, I haven't really said what velocity means, but it's a term, it means something. And V is the first letter of it. So if I want to talk about average velocity, I will put a bar over the V. So from now on, V bar means average velocity. I don't know what that means just yet, but that's what the notation stands for. Similarly, if I put a bar over any kind of squiggly, any kind of symbol, then it means the average value of that symbol. Okay. So here's our first equation then. And it's equation we were going to use, like, believe even whether you find this simple or hard, what it is true. And it's fundamental. We're going to use it whether you think this is really simple and easy, or you think it's hard and complicated, I'm sure there's both of you in the room. What it is fundamental and possibly more powerful than you might imagine. The one equation I want to establish right now for physics for going forward is this V bar triple equal sign X minus X naught over T minus T naught, like the yellow thing. I'll explain the red things in a second, but the thing that's in yellow, what is it? Notice it's a triple equal sign. So it's a definition. So this is not a discovery. This is not, if you're trying to understand what I mean by this, try to understand that really what I'm just giving you is an abbreviation, like a new piece of language. I'm saying that from now on in physics, all we're ever going to look at is how things move through space and time. So the first thing we're going to do is establish the simplest conceivable, the simplest conceivable relationship between space and time. We're just going to say to ourselves, from now on, I want to track when something travels through a chunk of space. I want to track the idea of how much space did it get through per how much time, right? Things can move only in two arenas, space and time. So the first thing we're going to start worrying about in physics is like, how are you doing in one arena in relation to the other arena, right? Of course, in English, of course, all of you are very familiar with this concept, especially when you think of it just in terms of speed. Like, you're all familiar with this concept before you take into account directions and stuff. We're talking about fastness here, right? We're just saying that someone who can cover 30 miles in 1 hour is moving faster on average than someone who can cover only 15 miles in 1 hour. So the rate at which you traverse a chunk of space per that chunk of time, we're going to call from now on your average velocity. I mean, we could call it average speed, and we do when we're not thinking about direction at all. But from the moment our x's and our x naughts are precise and could be positive or negative, forward or back, from the moment we're taking into account negative signs, let me back up. From the moment we're taking into account direction, remember, we're only in one dimension. So if we're only in one dimension, there's only ever two possible directions you can go, forward or backward, or left or right, or north or south, whatever you want to call them. But you have one degree of freedom. You have one set of choices, either there or the other way. So one way we call positive, the other way we call negative. And as long as we're taking that into account, as long as our positions could have positive signs or negative signs on them, then what we're looking at is displacement, not distance. And then the ratio of displacement to time, we're calling average velocity. Average. I am saying, and I'll go on in a minute. I know to many of you this is like duh, but I'm trying to but some of you it's not. And there's no shame either way. But I'm trying to establish like a couple of subtleties and ground rules for going forward. One is that what I'm defining here is average velocity. If I know for a fact that you took an hour to go 30 miles in the positive direction, like you took an hour to go 30 miles to the north, then I know that during that interval of an hour, your average velocity was positive 30 miles per hour. That's your average velocity. I don't know how fast you were going right at the first minute or in the middle, or like you could have been going faster and then slower and then faster, right? But if you covered a total of 30 miles in a total of 1 hour time, then on average, you were going 30 miles an hour. Positive. That's all I know so far. So the first thing we're first establishing a quantity that relates to intervals. Interval, you might want to write this in if you write this in your notes, what I'm about to say, because I can't like squeeze it in here. If you write this in your notes and upload it as an example of notes, definitely get points. In physics, there's two different types of quantities. There's quantities that apply to intervals, separations between two values, and there's quantities that apply to individual values, individual points. Let me say that again better. There's two kinds of quantities in physics: quantities at a point or quantities between pairs of points. I'll say it one more time. There's measurement at a point, such as position or instant, and there's measurements between pairs of points, such as displacement or average velocity. The reason we make a big distinction between points and intervals is, this is a part to write in your notes, measurements at a point, like how fast you're going at a moment, is much more precise and exact. That's the advantage. But the disadvantage is it's much harder to picture or measure. In reality, knowing exactly how fast you're going at exactly a moment is much more exact. But how do we actually visualize speed at a moment, or how do we actually measure speed at a moment? Much harder. So physics starts with looking at intervals between points. So again, just quick summary again, if you're taking notes, I'm saying there's points and there's intervals between points. Points are exact, but they're difficult to measure. Intervals are easier to measure, but they're not exact. They're averages. So we start with the latter. An average velocity is easy to measure. It's just how far did you get in a certain direction per how much time. It's not exact. It's an average. I mean, it's not exactly true for any given moment, but it's on average true for the whole. Okay, so average velocity is displacement per time. I'm trying to write it, the way I wrote it in yellow is to emphasize it's a definition. It's not a discovery. If you're trying to understand, wait, why does it work out that average velocity is displaced? It's not something we like figured out. It's not anything that could ever be wrong or that we could unfigure out. We're just saying, if you just want to divide how far you got by how much time you took, we have a word for that. It's called average velocity. Okay. And it just is the simple ratio of the space to the time. But now notice, I'm moving on. I know I'm like losing people to sheer boredom. I'm losing myself to sheer boredom. I understand. But now notice that since t, even though it's parallel, like the numerator looks just like the denominator on purpose, because we're just dividing one thing by the other, space by time. But T naught is always zero. So in fact, in general, we always write the equation in this sort of unbalanced way. We write it the way it is in red. I'm just trying to show you the reason so from here on in our equation, is average velocity is defined to be displacement over time. And it's written in the way that it's written in red. So that's like our big GDP from now on. Like that's the equation right on the front of the board, right? That. From now on, that is our one equation. Why is it true? Because we just defined it to be true. Like, why is a square four-sided figure with four equal sides and four right angles? Because that type of thing is what we call a square. Okay, so this is average velocity. So, okay, so we're about to finally get back to homework, I think. That's our one. Please stop me if I'm not making sense. Or also, you could always put in the direct chat, like, Professor, we get it. Please get to the homework. Like, I mean, if you do it politely, like, can you get points for that? But all right, but I think you get it. I mean, I know you get it. So we have this. So moving on. So now back to the homework, to part 3 of homework 1. Question 1, we had done the diagram. Question 1, we had done the step 2. What's the question? The question is right. The question is right here. Like at t equals 7, what's x, right? So now for step 3, we write our GDP. GDP means general definition or principle, something that is true in general, or like, so something that's true. Sorry, okay. Something that is true even before the problem started. Something that if another physicist were reading your homework, they would recognize as a truth, even if they didn't know what's going on in your homework. So step 3 is supposed to be something that is generally true. Now it could be written in English. Sometimes it is written in English, but as we get more and more into physics, it's generally written as an equation. So right now in this class, we really only have one real equation, the one I just gave you. So when in doubt, if your problems have anything to do with velocity or displacement or anything, I would write this one down. So this is my step 3 GDP. And what I'm really trying to encourage you, now that the homework is still, I think, manageable by most of you, but it's getting like a little bit thought-provoking, please notice when I get to step 3, I freaking just write this thing down, even if I don't know how I'm going to use it yet. Like, I think for many of us, not all of us, for many of us, this question 1, this second to last question of homework 1, it represents the first time where we're now seeing a question where at least for me, when I look at that question 1, I don't automatically see the answer in my head. Like, I mean, I know the answer because I've done it, but and maybe some of you do, and like, Quark bless you, but I don't automatically know the answer just when I read. Like, I think question 1 is just hard enough that I have to think about it, right? So not only do I not see the answer automatically, but I don't even automatically exactly see how to get it. I know I'm looking for position. Many of you will think, do I have an equation? Like, right? Like, question. So now I'm talking about like question 1 of part 3. It asks, what is the position at t equals 7? It's asking for position. So you might think, do we have an equation for position? No, I'm not as such. No, like, I've never taught like how to get position. We have one truth that relates to position at all. It's this one that I wrote down. So if it relates at all and it's true, if it relates at all and it's true, I write it down. Even if I don't know yet what I'm going to do with it, if it's true, I write it down. And part of and that becomes really important, that the harder these physics questions get. If something is true and it's remotely like within the topic, you write it down. If this were an exam right now, like, I'm honestly because we're already at the realm now where some people didn't know what to do here. If this were an exam, even if you couldn't get the right answer, you didn't know, or you stopped after this, if you wrote this down, v bar triple equal sign x minus x naught over t, you'd get points for writing that down, even if you didn't know quite yet what to do with it. So, and that's to enforce habit. Write things that are true and then start trying to make them relevant. Not the other way around. You don't have to see the end of the tunnel in order to start walking into it. Okay, anyway, so we wrote down step number 3, GDP. Now, the thing is, what I'm looking for is x, right? I'm not looking for v bar, I'm looking for x. So what do I do next? Before I go to step 4, I'm going to start applying this to the problem. Like, in this problem, I need to solve for x. So I need to start rearranging this equation to get x by itself. Like, I need to do some algebra. Later on, I would have to do some trigonometry or some calculus. Right now, it's algebra. So I multiply both sides. I do whatever the algebra is that's necessary to get x by itself. So I multiply both sides by t, and then I add x naught to both sides. So now I have something. X equals v bar t plus x naught. Now, please note, this is starting to look like physics now. Again, I'm just, like, we're evolving. Hopefully this isn't crazy. And maybe you didn't do all this and maybe you still got it right. But this is what physics work starts to look like. I've rearranged a truth into an equation that will help me now in this particular problem in step 4. But notice, it's now a double equal sign. It's no longer a triple equal sign. And the reason that that's important is I don't want you to think now that this is a new equation that you have to memorize. Like, first of all, you shouldn't be memorizing anything, really. But like this thing that I've written at the bottom of the page is just a result that is a discovery for this particular problem. It's just a rearrangement of a truth. It is not a new truth. It doesn't get a new triple equal sign. It doesn't go on your equation sheet or something like that. Okay. And furthermore, notice it's not something that I started with. It's something that I'm getting to. Physics looks more and more like algebra or trigonometry or calculus as we proceed. And notice I'm doing physics now without even having plugged in any numbers yet. One big habit, you might want to write this in your notes separately, is part of the step method is we try to postpone numerical values as long as possible. That becomes more and more important as we go along, and it becomes less obvious or less comfortable for people as we go along. The numbers are the last of our concerns. It's not a math class, it's a physics class. So we're trying for as long as possible to think of the problem as a general situation in physics, like given some amount of time and some amount of velocity, what would the position be? I don't care if it's this number line or that one. So I'm putting the numbers in last whenever I can. So I wrote x equals v naught t plus x naught. I'm going to say one last time, this is not a new equation for you to memorize. This is just a new arrangement of a truth. Where did the truth come from? Definition. All right, so I go to the next page. All right, so I wrote x equals v bar t plus x naught. Now, every time I use the word here, that really signals that I'm in step 4. I'm in the particular application of the problem, right? So now I'm going to apply like the subtleties that I was yelling about before. For the whole problem, the very initial position, for the whole problem, t equals 0. And for the whole problem, the instructor started at position +4. But I want to emphasize here, and I want to slow down a little bit, and like, please stop me if this is not clear. And we're almost done with this. That's the good news. So, because I know I'm just talking a lot, but here, the question is, to remind you again, the question is at t equals 7 seconds, what's x? Right? So if you look at that equation, if I'm just, it's asking me to ultimately substitute in a value for v bar, for average velocity. But if you think about the whole problem, there were different average velocities. There were 3 different intervals where the instructor moved at 3 different rates. How do you plug 3 different rates into one equation? We want a rate. So what should we do? We should zoom in our heads, zoom in to one particular interval that has one particular average velocity that contains the one particular moment in time in which we're interested, right? So the interval I'm going to zoom in on is the very last interval of those 3 segments in the drawing. I'm going to zoom in on the last segment of the drawing where the professor goes from position +4 to position -5 in 3 seconds. Right? Because that last interval contains t equals 7. This last interval, in other words, that I'm looking at is from t equals 5 to t equals 8. So 5 to 6, 6 to 7, 7 to 8, right, is the last 3 seconds. That's what I'm looking at. So for those last 3 seconds, the professor starts at, or the instructor, whatever, the particle starts at +4 feet. And when is he at 4 feet? He's at 4 feet at what the larger experiment calls the 5th second. I don't know if that's confusing. Like for that, well, I'm just going to stop me if it's confusing, but this last interval is from 5 to 8. So at the when the clock strikes 5, he's at position +4. And we are looking to see what happens over the next 2 seconds. Why 2 seconds? Because from 5 to 6, and then from 6 to 7. 7 is the moment that we're interested in. So I'm going to, now stop me if you want me to go. Remember, if you write in the chat or private chat, please go back or please turn the page back. Not only does that not bother me, but you get points for it. So please, if and also if I'm going too slow, if I'm boring you all to tears, I've lost you and you're all off getting cups of coffee, write in the chat, please go faster. I mean, maybe I'll make the judgment that that's just you, it's not everybody else, but you want to drive this class, not me. But anyway, we're just about there. So I think I'm going to plug in that v bar is -3 feet per second. The time is 2. The initial position is 4. Where did I get this -3? where I got this -3, it was directly the last question before this question. In other words, it's really important that we're not putting in the average for the whole thing. We're putting in the average for this interval. For this interval, he went from from +4 to -5. He went -9. He went 9 to the left, and it took him 3 seconds. So his velocity for this part was -9 over 3 feet per second. In other words, -3 feet per second. That was the answer to the last question. So that's what I put in here. The amount of time is from 5 to 6 to 6 to 7. So that's 2 seconds. And the initial position was 4. So if you're trying to be mathematical or equation-y about it, this is how you do, and you get that he ends that at that 7th second, he's at the position -2. Like, I don't think that's obvious. I didn't know that when I just looked at the question. Like, -2 is not a place that's ever mentioned in the prop. Like, it's not obvious. But basically what I'm saying in English, and you might have gotten it right. Maybe you could see it in your head once you work through something. But I think we would all have to agree. Even if I'm not saying you did it exactly everything I just did. Although, again, for full points, I want to see all these steps. But even if you thought about it a different way, or you didn't write all this stuff down, if you got the right answer, you had to do something in your head. And if you really break down what you did, you had to do something that looked like this. Maybe it was in English. Maybe you're just like, oh, I get it. All right, he's going -3 feet per second every second, and he starts at 4. So what you might have made a chart or broken down something where you're like, okay, he started at 4, every second he goes -3. So first he goes from 4 to 1, because he's going -3 every second, right? So in the first second he goes from 4 to 1, and then in the next second he's going from 1 to -2. If that's what you're thinking, I totally agree with you. And I'm not here to say that you're wrong or that you're stupid for thinking that. Go quite the reverse. You get it. If you're like breaking it down and seeing it in your mind that way, awesome. Then the only thing I want you to see is that's all this equation is saying. If you think you get physics, but you don't get these equations, I'm here to tell you that the equations are just a shorthand way of saying what you do get. So you just want to start expressing your thoughts in these ways, especially as the things get more complicated. But this equation is just saying that. It's literally saying it started at 4, and then every 1, it went back -3, and it did that twice. So 1, 2, 3, 1, 2, 3. So the answer is -2. That's the answer for that one. I'm looking at time. We have 17 minutes, so we're totally, do you have to do it exactly my way to get full credit? Not exact. You don't have to, it doesn't have to look exactly like mine, but you do have to have all the steps. And so I do have to see the diagram, or refer to diagram above, the question. I need to see somehow, there's no way to do this without somehow understanding that average velocity is displacement per time. You might not have written in an equation form, you might have written in English, or you might have, but this doesn't make any sense. It's not possible unless you understand that a rate is a space per time. So somehow you have to express that, and then you have to apply to the particular numbers and get the answer. So it doesn't have to look exactly like mine, but I don't see how you can do this in a way that's readable by anybody else without somehow incorporating those 5 steps in that order. So that's my answer to that. I'm going to pause for a second. I'm going to change the view on the screen. Hold on a second. Like, we have one more question to do and we're done for today. Again, we're not doing homework, but hopefully, but again, I think I told you at the beginning, what I'm doing now is all that no matter, I think homework 2 starts off warm-uppy. I think the last 2 questions on homework 2 are tricky. I'm not saying they're impossible. I'm not saying they're unfair, but I think you have to think about them. But I guarantee all you have to do is some version of this, of like understanding that average velocity equals displacement over time, and then being flexible about rearranging it. That's what you have to do to get the last 2 questions on homework 2. Again, I don't think the answer to the second to last question is 50. I think it's something else. Also, I noticed some of you totally did get it right, by the way, which is great. And I think some of you, let's be clear about this, some of you might have even gotten it right because you went to old class videos and saw me talk about this in prior semesters. Is that cheating? Absolutely not. Like, and do you have to tell me that in homework? No. I mean, I'm sort of curious, like, and I want to find out later, like, who's actually using these videos for what. But if you got stuck on a homework problem and you were resourceful enough and willing to spend the time to go back and see how I explained it in recordings of past semester, well, Quark, bless you. I mean, we might as well get some benefit from post-COVID education, right? Like that is not cheating. It's totally fine. If you literally do it all out the way I did it, and then you like claim that you made it all up yourself, I think that's, I don't know why you would do that. That's, disingenuous, but like, whatever. I mean, we're not asking who made up anything. We're just asking, is it correct? So anyway, so feel free. But what I'm really trying to say is, if you make like, okay, big hint that I'm really saying, here's the spoiler alert. Average velocity is displacement over time. Average velocity is not average of the velocities. I've definitely already seen this. If you have 50, what you're thinking is that average velocity is the average of two velocities. No one's saying that here. I'm not saying that's crazy. I'm not saying you're a criminal. I see where you're getting that idea, but you're actually making up that idea. That's not actually an idea. I mean, it's an idea, but it's not actually a true idea. Anyway, that is all you should have to be able to do to get all of homework 2 correct, which is still totally time to get all the points. All right, so it's 13 minutes left. That's that one. Let me just change the view for a second and just see. I want to do the last question, but it's actually, once you get this, it's not hard. So can I just pause? Just raise your electronic hands or whatever if you're okay. If you might be bored, but as long as you're clear. Cool, awesome, awesome. Okay, and keep them up for then. So that means I can go on. I'm going to go on to the last question. Yes, like if your hand's up, I'm taking it. I can go on to the last. Okay, and keep them up. Keep them up. Now, just raise your electronic hand if you're listening at all right now. If you hear me speaking at all, raise your electronic hand and keep it up. Keep it up. And this is obnoxious that I do this, but raise your hand if you hear me at all. Raise your hand if you exist. Raise your hand if you're breathing. Raise your hand if you're alive in the Zoom room. Okay, that's almost everybody. Okay, I'm not trying to embarrass anybody, although I'm really taking notes who's not. Okay, no, cool. You can you can put your hands down. Okay. And again, also I like you might be noticing the pattern already, or you might have noticed it in high school. Physics tends to be one of two things. It tends to be clear and then super boring, or it's exciting and confusing. Like I'm trying as hard as I can to like not make it either of those, but yes, it often is the case that if it makes sense, like you were like, duh. And but then when it starts getting cool, we're like, wait, what is going on? I know that. We're going to get more and more into the realm of where it's exciting and we don't know exactly what's going on. So in a way, if you're bored right now, I totally sympathize. And if you're not, I'm not saying you should be, but if you are bored, if you're just like, yes, go, I sympathize, but let's at least be clear at the beginning of the year so that we don't feel tricked when it starts getting harder. Right. Okay. So the last one. Yeah. So here's the last one. Oh, it gets very, why is it so, oh. Okay. And I think it all fits on this sheet. Yeah. So the last, all right, so I did it faster this time. So for the diagram C above, same diagram. That's step 1. Step 2, what's the question? The question is from t equals 3 to t equals 7, what is the average velocity? So this time we're directly asking, what's the average velocity? So we're not even going to rearrange the equation this time. So step 3, the GDP. Sorry. Skylar, sorry, is that a question, or you just didn't put you can put your hands down if you don't have a question, but if you have a question, definitely ask. Oh, okay, sorry, okay. All right, so here's our one GDP. And again, if there's any other takeaway, it's right now the only GDP that we really have in equation form is this. If you're saying something that doesn't mean this as a GDP, like in homework 2, something is going wrong somewhere. So this is our GDP. Average velocity equals displacement over time, defined to be displacement over time. Again, also, please note, we're not saying speed is displacement over, I'm sorry. We're not saying velocity is displacement over time. We're saying average velocity is displacement over time. I don't know what velocity is yet. Like, I don't know how fast something's going at a point. I don't know. But I know on average how fast something's going, and it's given by this. Okay, so now here in this example, we can actually, so step 4, we can plug in directly I tried to just do this all in one sheet. Maybe that was where, here, step 4, we could start plugging the numbers directly. We know that x naught is -2. Oh, because we're going, sorry. We're in this question, we're going from t equals 3 to t equals 7. So x naught means, see, this is just the one, x naught means the first position, like for this interval. Like this interval, we're looking from t equals 3 to t equals 7. So really in my mind, I'm thinking of t equals 3 as t equals 0, if that's not confusing. And so I know that x naught, I know that the position is -2 when time equals 3. How do I know that? Because the problem told me. If I go back to the original problem, it literally says, look, the professor went from 4 to -2. That took him 3 seconds. So at the 3-second mark, he's at -2. Then at t equals at t equals 7, where is he? Well, he's at -2. How do I know that? Because I just figured out in the last problem. So I scroll this, I compress this a little bit badly, but like v bar then equals -2 minus -2, like we're taking into account minus signs. -2 minus -2 over 4. Well, that's 0 over 4. Well, 0 over anything is 0. So the mathematical answer to this question is, oh, I see something in the chat. Great. I'm going to get that in 1 second. Awesome. Well, I'll just finish the sentence. Mathematically, the answer to this is 0 feet per second. I'm going to say physically, though, and then I'll get the chat. Physically, that's also correct. Like just from here on in, anytime you end up where you start, your display, your distance might be huge. You might go all the way over there and then all the way back. That's a lot of distance you cover. But if you end up where you start, then your total displacement is 0, no matter what. So the truism you could write in your notes, you can say for any round trip, displacement is necessarily 0. And what I mean by round trip, well, we're in one dimension. Nothing's actually round in one dimension. But I mean a closed path. I mean, if you end up at the same place you started, then your displacement is necessarily 0, even if your distance is huge. And therefore, your average velocity is necessarily 0. This is a huge distinction between average velocity and average speed. Not only can average velocities be negative, whereas average speeds cannot, but the fact is you could be running really fast for a long time. If you run around a track and if you run there and back, and you end up, no matter how fast you were running, no matter how high your average speed was, you didn't get anywhere. You weren't displaced ultimately. You didn't accomplish a journey in space. So your average velocity for any closed path is 0 necessarily. So that's a truism to take away. The average velocity for any round trip is necessarily, like always, 0 feet per second or miles per second or meters per second, whatever. So that's the answer to the last question in the homework. Now there is at least one thing in the chat, so that's great. I'm looking at the chat. Hold on, but we have 6 minutes, so it's perfect. I'm happy to take any and all questions about any of this now, because other than that, like homework 3, I'm sorry, Wednesday we move to homework 2, right? So I do expect that you've thought it through. And of course, my main focus on Wednesday will be the last 2 problems, which I'll also warn you, the last one is very similar to the second last one. So if you get the second to last one, and a lot of people did get the second last one, but didn't get the last one. If you get the second to last one, and I told you that you did, you really want to take that same concept and somehow try to apply it to the last one. I'll also say they're the same method, but yes, the answer to the last one is even slightly more unexpected than the answer to the second, but it's still legitimate. Whatever. All right, so let me look in this chat. So Oh. Well, this is a great question. Sorry, great question in the direct chat. Great question in the direct chat. Yes. So basically the question in the direct chat is like, wait, he or she is basically pointing out that in the homework, what I'm asking about is speeds, but every analysis that I just did right here was about velocities. That's a very good point. Very good point. So let me be clear. Um, it, a couple of things. Wait, but the question. Wait, the question asks about average speed. Actually, wait a second. I do see what, hold on, let me look at the question for a second. I think, well, actually, wait. So the very I, I think what's true is that the facts of this problem are given in terms of speeds. That is true. And that's important. The speeds are given in this problem. And the reason for that is right. It's not specifically telling, because it's giving you directions in English. So it's saying like it goes this way, then it goes that way, that way. But it's absolutely true. I mean, it's absolutely, it says each time it moves, its speed is constant. And each time it moves, its direction is also constant, right? It's just that they're not constant from one interval to the next. So first thing I'm trying to say is if its speeds are constant for each one of those intervals, I think, and if its directions are constant for each one of those intervals, I think it also is true. You can also infer that its velocities have to be the same for each one of those intervals, not the same from one interval to the next, but like, so I'm saying that, but then, so yes, it's giving you information about speed and direction, and we're sort of asking you to put together information about speed and direction to get information about velocity. I guess that's my point number one. But point and point number two is absolutely everything I just did. Everything I just did, I'm now starting to do an equation for, like velocity and displacement is ultimately really how we do physics from here on in. The concepts of velocity and displacement are built from the English concepts that we sort of feel like we already know even before a physics class of distance and speed. So what we're saying is we're building displacement from the concept of speed. We're building displacement from the concept of distance, and we're building average velocity from the concept of average speed. Therefore, we invent symbols and equations for these more precise things of velocity and displacement. Like those are the things that are easier to express in equations and symbols. Definitely, first of all, if what you're asking is, could we have done everything I just did on the board? Could you have done it all in English? Could you have done all of these steps in English and with words like speed and distance and gotten it right and gotten full credit? Yes. If what you're saying is, could I have done all of this? Like, if I didn't understand these symbols or equations, could I have done all of this with the definitions of in English words? Yes, you could have, and you could have gotten full credit. No problem there. But the one thing is, in the end of the day, the one thing I'm taking a slight issue with is I actually do believe that this last question, the last question does ask for average velocity in the interval 3 to 7. I think it does ask for velocity. So I think I am sort of doing the right thing. Again, I agree with you that the facts are given in terms of speed, but I think what we're being asked to do is build those speed facts and those direction facts into velocity facts. I'm not, I think it's a great question, but I'm not sure if I'm, homework two. Sorry. Oh my God. Thank God we have one more minute. Okay. The question's about homework 2, not homework 3. Okay. Bottom line, everything I just said apply. Yes, the questions are about speed. Yes, you're right. In homework 2, great question. And definitely you put us all in for points, all that. Homework 2, it's all asking about speed. But I'm telling you right now, you can use all these equations and do all this analysis of velocity, and it'll still get you the answers you're looking for. Because, for example, if you, in the end of the day, if you do all this equation stuff and you get that an answer is average velocity equals negative 30 miles per hour or something, then what that means is the speed is 30 and it's in the negative direction. So at the end of the day, you basically take the absolute value of whatever answer you get. And like that would be the answer to average speed. I mean, it's a great question. Sorry, I went off on homework 1. Now I see what you're, but my quick answer is feel free to do all this math. You can do this math. It'll work. Just be tracking, just note that everything you're going to be putting in is positive values, because everything you're doing is positive values because you're not worried about things changing their direction. I'm saying it to it. Do it this way, and then when you get a final answer at the end, you'll have an answer for velocity. Well, just take the absolute value for that, and you'll have an answer for speed. Okay, great. No, it was a great question. Sorry but I think that's it for everything. I'm gonna hang out for 2 minutes if anybody has any more questions, but it's 1:31. Definitely, I'll upload all this, blah, blah, blah. So try to do homework 2 or redo homework 2 for Wednesday. See you soon. Have a great lunch. Have a great community hour.
On your transcript as an